So as I said earlier, we need to go ahead and delay the simulation until a later frame so that we get a nice smooth surface, but also it's just unnecessary. We don't need to be simulating, especially when we bump up the particle separate or drop the particle separation. We don't need to be calculating all these frames until the strawberry actually contacts the fluid, right? So let's come down here to this angle and just take a look at when the strawberry comes into contact. Say about frame 60 there. Yeah, so I'm gonna set the start frame on my dot network to frame 60, so nothing will happen before that. In fact, if we come inside, you can see it's empty. Okay, I'm also going to raise the substeps now to 3. Okay, so this will, again, to reiterate, every frame it will calculate the velocities and the position of the particles 3 times, right? So it will, it's giving us, it's giving the solver more chance to correctly solve the calculations, you know, to find the correct position for the particles, and it can change the look. So we're going to do it right now. What else did I want to do? Let's go ahead and start raising the particle separation, or dropping the particle separation. I'll come to frame 60 just so we can see what we've got. So there we can see it's way too coarse there. So I'm going to drop it down to 0.5. It's a bit better, but still, you know, we'll have to drop that again later. And because we've got more particles there now, we can go into our initial fluid and drop the layer size. We can do that to about, let's do 0.1. Okay, which looks very thin, but that's fine. I'm also going to come up here to the surface evaluation, use this to add in even more particles to our initial state. 2 and 2 there. Okay, let's head back up here. Now, while we've got a nice camera angle from the top, but you know, for our final render, it will look great. But when we've just got particles without a surface and without any lighting, it's a bit difficult to see what's going on. So I'm just going to drop not the camera, but press spacebar and F and look at it from about there. So another very important thing, which I haven't done yet, if you remember, this strawberry is falling in slow motion. The RBD solver, we changed the actual time scale on that. We have the same thing here on the flip solver. So we got this time scale here, which we can drop. I'm going to drop it to 0.25. Okay, so that will be running at a quarter of the normal speed. So let's take a look at the flip book there. So nothing's going on until frame 60, so there's no point of saving a flip book with that. So let's go from 60 to 100, just do 40 frames. That should be enough. Let's start that and see what we get with those values. Right, that's all done. So let's take a look at the results. So obviously we're getting a way bigger splash now. We're starting to see this typical, what people call a crown splash. This kind of ring of fluid around and then this spike in the middle. Okay, so I'm going to stop that, and maybe we can do some more changes, and then to compare the flipbooks, if we come here to render and go to new sequence, then when we record a new flipbook, it won't record over this one. We'll be able to make a comparison between the two. Okay, well, I'll leave that for a moment and just minimize it, and let's see what changes I want to make. So we definitely want to go ahead and jump into our volume motion, and we want to add some surface tension. Okay, not too much. I'm going to drop this down 0.75, just a bit here. And we want some viscosity as well. Okay, so if you remember, just to explain again, we have covered this, but the surface tension will try to round out square, not square, but sharp edges, right? So if you think about when we did the example with the block of fluid dropping, it just instantly begins to turn into a sphere. So it depends on the curvature of the surface of the fluid. It's trying to form these kind of globule tendril shapes, right? Viscosity will give us a thicker effect. So just turning it on here won't do anything. We need to go into our flip object and to the physical and give it a value here, right? So I'm going to do, again, something quite low, just 0.5. We're not going for, yogurt or something really sticky like that. Just hopefully it will help it hold together a bit. What else can we do? Let's see. Oh, here also the same. We also covered this in the last lesson. These two options. So splashy kernel is more for if you're doing a big river or an ocean, part of the ocean, or something with a lot of noise on the surface. But we've got something with a much smaller scale, so we go for a swirly kernel. Okay. Let's see. I'll leave everything else for now, and the substeps will leave. But I'm going to drop the particle separation again. Oh, I'm going to drop this to 1. So particle radius scale. As you can see there, setting this value higher will result in more volume in the fluid. So we're not too worried about that, but less surface detail. So I want to get a lot of nice fine detail. So I'm going to drop this down just to 1, and also try pushing this down. That didn't take too long to calculate that last flipbook. So I'm going to go to 2.5. You see the density changing there. Okay. Maybe even further. Let's go to 2. Great. I should have left the camera there, but that's okay. We can run another flipbook. So remember, if we go back, find our flipbook, go to render and new sequence, you won't see anything change, but hopefully now when I run another flipbook, it won't go over this one. And I'm going to come here, flipbook with new setting, 60 to 100, that's fine, start, and let's see how that comes out. Right, that flipbook it's not completely finished, but I stopped it a bit early. It was taking quite a while, but we've got enough to see that it's quite a lot different. So it's getting this nice crown around the strawberry now. The fluid's holding together. We can see the viscosity, even this kind of tendril sticking to the side of the container there. Kind of looks like a glass wall, but we won't see that from our point of view from the camera. But we're getting some nice shapes now, these nice big blobs. We're getting a kind of thick rim around the edge as well, which will look nice in the render. These ripples, it's coming together much better now. If you want to compare the two, if you come up to Windows and come to Sequence List, I've already got it open here, there. So there we got the two, so we can just go between the two, check the render flag on each one, and you can just play through like that. You can see a massive difference there. Great.